All right, so in this video, we are going to talk about how to solve, or really not to solve, but to set up application problems that involve three variables and three equations. Solving has been in the previous two videos. So a lot of times the first thing I like to do in these questions is actually skip the first couple of lines and go straight to the question. The question says, how many 3-point, 2-point baskets and free throws did Dampier make? So this tells me what we're trying to find in this question. So it also tells me what my three variables are going to represent. So I'm going to let X represent the 3-pointers. And really it's 3-point baskets. I'm going to let Y represent the 2-point baskets. It's actually how many 2-pointers Dampier made. And Z is going to represent the free throws, which of course are really just 1-point baskets. So there's my three variables. Now I need to determine the three equations for this problem. In almost every single application problem, there is going to be basically like a total equation or an equation where you're summing the three variables together. And that happens right off the bat because they tell us Dampier scored a total or a sum of 13,726 points in his career. So that means in this problem, every X is worth 3 points. So we're going to add 3X to 2Y because every Y is worth 2 points. And then plus 1 times Z because every Z is a free throw and it's worth 1 point. And when we total those baskets after we multiply them by their point values here, it should equal 13,726. Notice we only use those multipliers in this first equation because we're talking about total points and not total baskets here in this first equation. All right, so if we keep reading, the next number we see comes right here where it says Dampier made 2,144 more 2-point baskets. So 2-point baskets means we're referencing Y. And in this problem, it's saying Y is equal to 2,144 more than the free throws, which are represented by the Z variable. So that's our second equation. A lot of people make the mistake of accidentally putting the 2,144 on the left-hand side. But since in the problem it says Dampier made 2,144 more 2-point baskets, that means Y should equal 2,144 more than Z. So this is the correct setup. And then likewise, very similar for this third equation, Dampier scored 1,558 more free throws. Free throws are represented by Z. And he scored 1,558 more of those than the 3-point baskets in this problem, which are represented by X. So there's your three equations. So now you're ready to go through the solving process. Again, we're not going to provide that in this video because that was the focus of section 1 and section 2. Let's finish with number 2. Go straight to the question. The question is, what are the measures of the angles? Okay, so that's not very descriptive in this problem. So if we go back and we look, they're talking about triangles. So of course we know in a triangle there are 3 angles. So that means each variable is going to represent an angle in the triangle. You could call this first, second, and third angle. You could call this small, medium, and big angle. Doesn't really matter. Just so you know, each variable represents a different angle in this triangle. So like we said earlier, there's always a total or sum equation. So our sum equation in this problem, this information isn't actually provided in the setup, but we know the three angles of a triangle add up to 180. So there's our sum equation. We can read through the question to get the other two angles. The next thing it says the measure of angle X and I just realized they're using X, Y, and Z. So we'll just say X is the X angle, Y is the Y angle, Z is the Z angle. But the measure of angle X, so I'm going to write X, is 8 times the sum, so the sum implies addition, the sum of the measures of angles Y and Z. This is implying we're finding the sum of angles Y and Z first and then multiplying it by 8. It's 8 times the sum. So that's our second equation. And then finally, our third equation is found by the measure of angle Y is 3 times the measure of angle Z. So there's your 3 equations. If you're struggling to solve these, reach out to me, let me know. But that's how you set up these problems. Most of these problems are very similar to that format.